Hello, everyone. Just want to let you know as you file in, you are in the right place. Going to get things going in about another minute as more people join us. But again, we appreciate you being here today. Again, we thank you all for joining us. Going to allow about another 30 seconds or so for everyone to file in and get settled. And thanks for being here today. Again, get going in about 30 seconds. Well, an official hello, everyone, and welcome to today's Safety and Health Magazine webcast, Simplifying OSHA Rooftop Fall Protection Requirements, sponsored by Key Safety. My name is Kevin Drewley. I'm an associate editor with Safety and Health Magazine, and will be moderating today's session. Thanks for joining us. In a few minutes, we'll start our presentation, but first, let's review some preliminary items. The views of today's speakers and organizations are their own and may not necessarily reflect those of the National Safety Council or Safety and Health Magazine. Any mention of a commercial enterprise, product, or publication does not necessarily mean the council or magazine endorses those items. At the end of today's webcast, we'll conduct a question and answer session. To ask a question, simply click the Q&A button at the bottom of your screen, type your question, and click the Send button. Feel free to ask your question at any time during the presentation. You don't have to wait for the question and answer session to begin. We'll try to answer as many questions as possible, but because of the large number of participants today, we might not get to every question. Any unanswered questions will be forwarded along to today's speakers. At the end of the webcast, you'll also be asked to complete a brief evaluation survey, and we'll let you know more about that after the presentation. This webcast will be archived, so you can access it after today's live event. To view this webcast and all of our past webcasts, please visit safetyandhealthmagazine.com/events. With that, let's go ahead and get started. Our speaker today is Dan Huntington. Dan is a general manager at Key Safety who brings experience in sales and technical product training with a demonstrated history of working in the fall protection industry. He's an industry expert with formal training in OSHA fall protection standards and risk assessment. Dan spends much of his time on behalf of Key Safety, climbing on rooftops, assessing hazards, and providing life-saving solutions for a wide variety of industries. Again, we thank you all for tuning into this presentation. Dan, whenever you're ready, go ahead and take it away.
Thank you, Kevin, and thank you, everybody, for taking an hour out of your day to hang out with me and us over here at Key Safety. And thank you to Safety and Health Magazine for hosting us on this, what I believe, and I hope that you guys believe, this very important topic. My goal today, as we mentioned earlier and in the title, is to take kind of this daunting, maybe complicated concept of OSHA requirements surrounding rooftop fall protection. We're going to break it down. We're going to make it easy to understand. And we're going to go very logical approach, how we would take a big complicated issue and make it as simple as possible. So with that, as we get started, I always like to start my presentations by making three promises to everyone. Promise number one is that I am going to make the knowledge as applicable as I possibly can to all of you. So this is not like big theoretical concepts. This is, I have a facility, I need to make it safer. How do I do that? Boom, we're going to do that. Number two, I'm going to be as engaging as I possibly can. Now, obviously, that's more difficult given the fact that this is a webinar. You probably are writing an email right now, or you have a phone call that's coming in, or somebody's coming into your office. So I'm going to be as engaging as I possibly can to try and get the information across, because I believe what we're sharing today is very important and will prevent accidents in the future. But if I can't present in a way that makes you listen, then what's the point, right? We didn't achieve the goal. Promise number three, this is not a sales pitch. I am focusing on the OSHA regulations and the application of the code and answering frequently asked questions that I get all the time after doing this for the last 12 years. We will talk briefly on the solutions that Key Safety manufacturers to solve these hazards that we'll talk about, but I'm going to intentionally move past those details quickly to stay focused on the job at hand, which is to educate surrounding the OSHA requirements. So, what are we here to talk about? Well, like I said, I've been doing this for about 12 years. And what I noticed in my time is that it didn't really matter in if I was walking on the roof of a hospital, a university, a manufacturing plant, a distribution center. Every roof had the same three hazard that I kept coming across over and over and over again. So what I want to do is identify the three most common rooftop hazards. So if you have a roof, you more than likely have these three hazards. We're going to talk about the OSHA code and what applies to them. We'll talk about how to protect them, frequently asked questions that we get, so nuances in the code. And then I think the most important theme, the kind of meta theme in this entire presentation is the order in which I'm presenting these hazards. Because if you're my client, again, most of my time isn't on the computer or doing webinars. Most of my time is meeting with you in the field, walking your roofs, talking about your issues. So most of the time, what we're trying to do is take this big project, this big daunting project, and break it down into very reasonable or logical steps and tackle it. So I want you to pay attention to the order in which I present these hazards, because it's the order in which I think they should be tackled. That's how we should prioritize them. And all we need to do is just make continuous progress, one step at a time, to be able to get, if we can solve one problem today and another problem tomorrow, by the end of the year, we'll have a much safer working environment on the roof than if we had done nothing, right? So it's all about taking a big project problem, bringing it down into bite-sized chunks, and taking care of it one step at a time. So I hope all of that as an introduction makes sense. So let's dive into the meat and potatoes of the content. Now, if you're my client, I want to kind of set a stage, okay? I want you guys to visualize what I typically see. Typically, I'll come out, I'll meet you. You're a building owner, you're a safety manager, you may be a specifier, architect, or engineer, but you're in a facility that you have concerns with the work going on the roof, the maintenance of the facility. And so we'll sit down, and chances are, I'll start the conversation by asking something along the lines of, hey, why don't you tell me a little bit more about why you've agreed to meet with me today and your concerns. And the chances are that the concerns that you have is the leading edge of the roof. You've got work or units near the edge. You don't want people to, fall off the edge of the building. So that's your primary concern. And I would say, absolutely, we need to address the leading edge. But before we even get there, the first thing that I want to talk to you guys about is how are we getting on the roof in the first place? What do the access points look like from the ground to the roof? Now, in a minute, I'm going to justify why I think that these are critically important and one of the first things that you need to protect on a roof, and in my experience, extremely overlooked. But let's first just break down the code and let's understand what OSHA has to say. So first lesson in OSHA that I'm going to give is the difference between general industry and construction. OSHA has different books, right? OSHA stands for the Occupational Safety and Health Act. So it is a law. And the act or the law has different sections. There's a section in the law that applies to general industry and a section that applies to construction. Construction law applies when the building is being built or like a major rehab is being done, right? Any code that is going to be under the construction portion of the law is going to start with 1926, 1926. What we're talking about today, this code starts with 1910. That means that we're talking about general industry, which applies to all work being done to maintain the building during the lifespan of the building. So if the building is 100 years old, it was built for 1 year, lasted 100, we're talking about the 99% lifespan of that building. And all the work that is done on and in the building falls under this jurisdiction in the federal code. So we're going to talk about 1910 and then 0.28. So the 2.8 is our chapter, right? So 1910 is general industry. 0.28 is the fall protection chapter or regulation in general industry. So that's what we're kind of diving into is fall protection in general industry. If it was in construction, we'd be talking about 1926.500, somewhere in there. But we're in the 2.8. Last thing I want to point out is that this code, 1910-2.8, was updated. The fall protection code used to be the 1910-23 chapter. And in 2016, that code was updated for the first time in about 40 years to have the codes that I'm showing you guys here today. So if you're referencing a code, or if your safety manual references 1923 and you're Googling trying to find the code and what it says, it's just an outdated code. You need to be updating to the 1928. All right, so crash course in OSHA is done. Let's dive into what OSHA has to say on access points. OSHA breaks it down and says that each employee must be protected from falling into a ladderway floor hole or ladderway platform hole by a guardrail system and a tow board erected on all exposed sides, except at the entrance to the hole where a self-closing gate or an offset must be used. Okay, so OSHA is a law and it was written by lawyers, right? I always say OSHA is written by lawyers for lawyers. So it doesn't make sense. They don't use the same kind of layman terminology that we do. So we have some weird terms in here. So let's break it down. It says each employee must be protected from falling into a ladderway floor hole. Well, what is a ladderway floor hole? Well, in this case, the floor is the roof. The floor is your walking working surface, which is the roof. And the ladder is coming up through a hole in the roof. What we would call it is a hatch, right? Circled on this photo on the right. We would say a roof hatch. OSHA says ladderway floor hole. Or a ladderway platform hole, which is where the roof is acting as a platform that I'm stepping onto and off of to get work done. And the ladder is on the side of that work platform. We would call it a fixed ladder on the side of a building. And it's just saying that we need to protect those access points, those ladders, with use of a guardrail on all exposed sides on either side of the ladder, except to the opening of the hole where I have to step on and off of the roof. And it says where, in that case, where that is, we need a self-closing gate or an offset to be used. So if I'm going to walk through an opening at the top of a ladder, there needs to be a gate on the top of it that opens up and closes behind me. Or I can use what's called an offset. Offset, think of that as like a turnstile at the bank, right? I need to turn right, then I turn left. Sometimes we'll design it as like a cattle chute to bring people into the middle of the roof because we can dictate walk paths that way easier. But either way, any access point needs to be protected, whether it's a ladder on the side of a building, a hatch, a man door on the side through like a penthouse or something like that. It needs to be protected by guardrails on all exposed sides, except for where I'm walking through. That's where I need to have my self-closing gate. Very simple, easy to understand regulation. The real kind of key here is, why am I presenting this first? Why am I saying the first thing that we need to do is to protect our access points? So the way I justify that position is to first understand how we assess risk in the first place. To do that, we use what's called a risk assessment matrix. I'm sure many of you are extremely familiar with this tool, but I'm going to walk you guys through it. In a risk assessment matrix, we rank the potential severity of an accident happening on a scale of 1 to 5, 5 being the worst, and we multiply that number times the likelihood of that accident occurring from 1 to 5, 1 being the lowest, 5 being almost certain that the accident will happen. Then we take our number and we get either a neutral, moderate, or critical risk rating. And that helps us prioritize which areas we need to protect first, right? We want to hit our critical hazards as the priority. So let's apply this knowledge to fall protection. So in fall protection, the potential severity of an accident is always a 5, right? The minimum height where OSHA requires fall protection in general industry is 4 feet. So any work 4 feet or higher, you need to have some form of fall protection. In construction in 1926, that number is at 6 feet, right? So a minor difference between the two. So severity is always a 5. Let's pretend you're sitting at a desk right now and that's 4 feet high and you are 6 feet tall and you stand on that desk. Your head is 10 feet above the ground and you fall backwards onto your head. We're at a potentially severe, potentially fatal or serious accident in that event. And we're at the minimum threshold, right? When you fall, the speed at which you fall is 34 feet per second squared, which means that you're going to fall 90 feet in under 3 seconds, right? It's almost the blink of an eye is how quickly you would fall 90 feet. The amount of force that's generated if you were to jump, let's say you're standing on your 2 feet, you jump, maybe you get 4.5, 6 inches off the ground, something like that. If you're me, maybe not even that high. You're going to generate 4 times your body weight in force in just that amount of a drop. So again, we're talking about a serious potential injury that a lot of people don't actually take seriously when they work at heights until an accident occurs. So every injury we have to treat like it's a 5. Where we get kind of, I don't want to say, confused, but where it becomes kind of subjective is when we're trying to understand the likelihood of an accident occurring. This is what I hear when I go on site. I hear people that go, well, we've never had an accident before, so we won't have an accident now. And they go, knock on wood, right? Well, knock on wood is part of your safety plan. It's not a good safety plan, right? Or they say, well, our guys aren't risk takers, so nobody's going to fall. I heard somebody tell me, I'm not scared of heights, so I don't need to use fall protection. No, that's not how this works, right? What they're trying to do is rate the likelihood of an accident occurring, but they're using extremely subjective terms, and they're not using objective or measurable terms at all. And I see this every facility that I walk into. So to go from the subjective to the objective, what do we need to do? Well, let's get the highest predictor of likelihood that we can measure. So it's really easy. All we have to do is swap out the word likelihood with frequency of exposure to the hazard. So the higher the frequency of exposure, the more exposure that I have to a hazard, the likely I am of an accident occurring, right? Statistically speaking, we're more likely to drown in a swimming pool than in the ocean because we spend more time swimming in pools than in the ocean. Pools aren't inherently more dangerous. We just have higher exposure. You're more likely to crash a car than you are an airplane. You spend more time driving your car than you do flying in airplanes. It's not that one is inherently safer than the other. It's all about frequency of exposure to the hazard, right? So let's take this concept. Let's apply it to an average roof. Okay, so this is an average commercial roof. Let's say, just for the sake of the example, that on separate trips, I can't stack my maintenance here, but on separate trips, I have to maintain these units on this roof. My primary access point is this hatch in the middle. Okay, so we'll just pretend, again, for the example, that doesn't exist. So twice a year, separate trips, I have to come up and I have to service this unit up here, right? It's an exhaust fan. It's got belts in it. I'm changing out the belts and I'm doing PMs on the motor. So twice a year, I'm up there looking at that hood. Once a year, I've got to reseal this skylight because skylights leak a lot and are always needing to get resealed. So once a year, I'm up there resealing that skylight. 4 times a year, I'm working on this unit that's super close to the edge. And we got PMs, we got filters to clean, I've got motors, I've got belts in there. So 4 times a year I'm there. And then spring and fall, I'm working along this edge, cleaning out these ductworks, right? We've got cottonwood in the spring, we got leaves in the fall, right? So I got to take care of that. So it's a really typical roof. The question is, which hazard is the worker exposed to most frequently by count only? Well, a lot of people say, well, the edge, right? Because I'm here 4 times and I'm here twice. So this edge is a 6x exposure count in a year. Some people say, no, it's actually the access point because every time I come up, I need to go through my access point. All right, yeah, you're right. What's my exposure count? Well, it's 2, plus 1 is 3, plus 4 is 7, plus 2 more is 8, or sorry, plus 2 more is 9. So I have a 9 times exposure count at my hazard, right? Wrong. Because I'm exposed, I need to come up and I need to come back down. So I have an 18x exposure count at my access point, which is exponentially higher than anywhere else on that roof. So that's why I rate that as one of the most critical areas to protect. Now, it's important to note that frequency hazard count is only one factor. Time of exposure is the other factor, right? So we still have to protect other areas on the roof that I'm exposed to longer, but it's a valid point around the access points. How are we getting up there to make sure that we're keeping them protected and safe? And nobody thinks about access points. When I walk on your site, the only thing you want to talk about is the leading edge. And I'm like, guys, we got to zoom out here. How are we getting there? What's our traffic look like? How often are we working up there? We need to understand frequency of exposure, time of exposure to get the best possible solution as quickly as possible at our critical areas. Some frequently asked questions around access points. The first question, I don't get actually as much as I used to. Basically, so here's the question I get is can I use chains instead of a self-closing gate at the top of a ladder, right? And the answer is no, you can't. But you used to be able to. And that's where people get confused. So back in like the 1980s, somebody wrote a letter of interpretation asking OSHA if you could use a self or a chain at the top of a ladder. Well, at the time, the code was still the 1923 code before they updated it. And they didn't describe the gate in that code as a self-closing gate. They called it a swing gate. So you'd have to close the gate behind you after you got into the roof. In the new code, they updated that language to call it a self-closing gate. And if you go into the Federal Register, which is where OSHA had to document the justification and reasoning behind every change that they put into the code, they very clearly state that chains are no longer allowed for use as fall protection at the top of a ladder. And they very plainly describe why. Number one, nobody closes the chain behind them after they get on the roof. Obviously, nobody's going to do that. But number two, when I'm climbing off the roof, so I'm getting off and I need to grab the chain and attach it above my head as I'm hanging on the side of the building, that's a potentially hazardous act. And if my safety requires me to be put in danger, it's not good safety. Right. And that was the real reason for it, is that it didn't make sense. So there's no grandfather clause, there's no exceptions. It is the new code as of 2016, so it's not really that new anymore, is that all ladders need to have a self-closing gate at the top of it with guardrail on either side. That's what a compliant ladder looks like. The other question that I get a lot is about the height of the ladder. What do I do if my ladder is over 24 feet tall and I have a cage and it's after November of 2018, so there's a requirement? What's the law? So it's really easy, guys. The new OSHA standard regarding ladders is that any ladder over 24 feet needs to have a vertical climbing device on it. It could be a rope that you connect to. It could be an overhead anchor point that you tie off to with an SRL. It could be a track system that you tie off to. Either way, you're wearing a harness and you're tied, you're connected to your ladder. You can have a cage. So cages aren't banned. They're just not considered as fall protection. They actually don't work as fall protection. They're just a mangler. They just mangle you up as you fall. They don't do anything to keep you safe. And you need to have every ladder that you install, if it's a new ladder or you're doing a repair to a ladder that's 24 feet or higher, needs to be retrofitted with a vertical climbing device. And then by November of 2036, so 12 years, mark your calendars, we have to get every ladder in America updated with a vertical climbing device on it if it's over 24 feet. So set your calendars, guys. We've got 12 years and about 8 months to make this thing happen, to make sure that we're in compliance. But the retrofits, anything new, any repairs, we need to be integrating them now, right? It's that simple. As far as solutions, if you've got a roof hatch that you're using to get up onto the roof, we integrate a guardrail. It mounts to the drip edge, so we're not poking any holes in anything. We're integrating a gate. A lot of times we like to integrate grab bars as part of the system, so just to make it easier to get in and out of the hatch. I mean, I climb through hatches every week without fall protection on them, and it's miserable, especially going back down without something to grab onto. So we like to integrate grab bars onto that. If I've got a fixed ladder on the side of the building, we integrate our non-penetrating key guard system. We'll mount onto the ladder and we'll integrate the gate onto the railing. So what we do is we install the railing on either side, the gate mounts to the railing, and then we connect the railing to the ladder. Just don't connect the gate to the ladder. There's nothing worse than trying to climb a ladder, and at the top of the ladder where that flare out is, I've got a gate that's trying to pinch my fingers as I'm trying to climb through, right? It's super annoying. A properly installed gate, you shouldn't have to touch with your hands at all, right? You just walk through, your body pushes it open, and it closes behind you. You shouldn't have to push it out of your way. It shouldn't hit your hands, nothing. Just walk through. It needs to be integrated into the railing and not onto the ladder. It's so annoying. I've dealt with it hundreds of times, and there's nothing worse than that. So this is kind of my, I would say, point of reflection, right? We just got done talking about access points. Think about your facility. How are you getting onto the roof? Is it a hatch, fixed ladder, staircase, penthouse? How are we getting from one roof to another roof? And are they protected? Do I have a guardrail? Do I have a gate? Is the gate integrated on the guardrail or onto the ladder? Think through that path. And if you're not in compliance, that's a great place to start so that we know that we're at least tackling our most highest exposure count hazard before we start to tackle other things. All right, so talked about access points. Let's move on to the next most frequent hazard. The next hazard are skylights. OSHA calls these holes in the roof. Statistically speaking, you're actually more likely to fall through a roof than off of a roof. I think there's a few reasons for this. Reason number one, a lot of the facilities that you guys manage or that you're responsible for, they're a football field wide, right? Sometimes, I've been on roofs, they have bikes on the roof. They're so huge to get from one end to the other. It's like, this is crazy. I'm on the roof. I'm 300 feet away from the edge. I'm feeling pretty safe, right? When I'm near the edge, it's this core, almost instinctual fear that's in you. You feel it on the back of your neck, right? That spidey sense starts to go off. I'm near something really dangerous. I don't like this. I'm being super cautious. I'm 150 feet away from a roof edge. I'm up on the roof. I'm feeling pretty confident. And I don't realize that translucent dome right next to me is basically a hole that I can't see through. And that, I think, trips people out. So I think that's number one, is instinctually we don't see it as an issue, as a danger. And number two, what happens to skylights when they get something over top of them, right? What happens to skylights when there's a little bit of snow on the roof, maybe a little bit of dust on the roof? You get that sun blindness, white roof with a white dome, and it's really bright outside. They're hard to see. The skylights are hard to see, and you can step on one without realizing it, and you can fall right through. Well, let's dive into the code and see what the code has to say. This is OSHA 19.10.28, paragraph B3I, states that each employee is protected from falling through any hole And then in the code, in parentheses, it says including skylights. So OSHA's super clear. That's 4 feet or more above a lower level. That's one of the instances of our 4 feet minimum fall height requirement in general industry by one or more of the following options. So OSHA now gives us options. In access points, there's no options. Gate, guardrail. That's it. Self-closing gate and a guardrail. That's what you have to use. Now we have 4 things to pick one. 2 are good, 2 are bad. And I'll explain what I mean by that. Number 1 is a cover. Cover the hole. Makes complete sense. A lot of times you put a screen over the hole so the light can still get through, but somebody can't fall through, is your most typical way of doing that. Option number 2 is a guardrail. You got a hole, put a railing around it so you can't fall into the hole. Complete sense. And then we get 2 new terms here that we have to define: travel restraint and personal fall arrest. So if you don't know what those mean, I'm going to give you all a 30-second competent person fall protection course. So if you ever signed up for your competent person fall protection course through OSHA, you know about the ABCs of fall protection. A stands for anchorage, B stands for body harness, C stands for connector, connecting your body harness to the anchor, right? You can design those systems in restraint or arrest. What that means is if I'm designing a system that's in restraint, my connector, the thing that's tying me to the anchor, which is called a lanyard, is shorter than the distance between the anchor and the edge of the building. So basically, I'm on a leash and I'm tied off in a way so that I can't fall off the edge, right? So I always say, picture it like this. You're walking down the sidewalk and you hear a dog start to growl, right, on the porch. And you're like, oh man, this dog's going to attack me right now. And it jumps up and the dog's, you hear that chain start to unravel, right? And the dog's running, he's barking at you, And all of a sudden, right before the dog bites your ankles, the chain goes tight and he just stops right before he can get you on the sidewalk. Same idea, but on a roof, and you're the dog. I don't know the best way to explain that, but you're on a leash and you can't fall off the edge because your lanyard is too short. Personal fall arrest means that I am tied off to an anchor. I can fall off the building, but my lanyard is going to keep me tied to the roof, to that anchor. And it's going to have an energy absorber in it that basically expands or stretches as I fall to slow down my fall in a way that won't hurt my body and in the amount of force that won't get me hurt. On average, in that case, you're going to fall 12 to 17 feet, depending on your setup before you're slowed down. So let's once again apply that knowledge to fall protection. So let's say this is the skylight that I need to try and protect right here. And let's say I'm tied off and I fall through it. Well, what am I going to hit on the way down? Right? I don't know because I don't know what my fall clearance is below that skylight. So fall arrest or active fall protection around skylights is super dangerous because we don't know what's below the skylight. And not only that, I need to break through the dome, right? My body is going to fall through the dome. I'm going to break it open. I'm going to get cuts on my body. And then what happens to the people below the dome after I fall through it and everything breaks? There's the shards coming down. I'm probably bleeding. So there's biological contaminants down into that area. It's a manufacturing plant. If it's a food processing plant, if it's a retail space or a university, there's so many other implications beyond just the fall. Even if I am tied off and I safely arrest my fall, what are all those other trickle-down effects that make using these 2 options just not practical, right? So that's what I mean by I've got 4 options, but really 2 options that are actually practical. Frequently asked questions around skylights. Number 1, is my skylight fall protection rated? And the answer is probably not. Now, here's the reason. Skylights aren't really made out of glass. They're made out of plastic. The way that you make a skylight is super simple. You get 2 pieces of plastic. You warm the top one up a little bit. You get pressurized argon gas. You inject it in there. That's a thermal bridge. You put a little pressure on it, it bubbles up that skylight on the top, everything cools, you got a skylight. That's how you make them. They're really easy to make. But then you install that plastic dome onto a roof and it sits in the sun every day for years, right? And what happens is a phenomenon called UV degradation. Believe it or not, you guys are all very familiar with this phenomenon, but maybe not as applied to skylights. I want you to picture summer's in full swing here in Buffalo, New York. It's beautiful. Picture the family barbecue, right? Coming up 4th of July. You just hit the buffet, got a full plate of food. You're walking up to that plastic chair that's been sitting outside, that white plastic chair. It's been sitting outside for 3 years. It's starting to get cloudy, right? That cloudiness is the plastic starting to break down. And you're eyeing that thing like there's no way this thing's going to hold me. There's no way this thing's going to hold me. And you sit down, all of a sudden, boom, the legs go out from underneath you because the thing is so brittle. It's been sitting out for years. Same thing happens to skylights. So just because it's plastic and just because maybe when it was installed, it was really strong, doesn't mean that it could hold your weight today. Many manufacturers will put a sticker on the skylight that says danger, risk of fall. But here's the bad news. They make the sticker out of plastic. So about the time that sticker's been burned up and is gone is about the time that skylight's like super dangerous and you're not going to see it anymore. So skylights, they need to have some form of protection around them or over them to make sure that they're safe. The next question that I get is about burglar bars. So grid on the inside of the dome. So underneath the plastic, sometimes you'll see a grid there. Is that fall protection? Well, I can tell you it wasn't designed for fall protection. Those are called burglar bars. It's really easy. You guys have probably all seen them, didn't even know it. Go to Walmart and look up. Every skylight in Walmart has bars on the inside of them. The reason for that is that so would-be burglars won't, grab a ladder, climb up onto the roof, smash open the skylight, zip line down into the building, stack a couple Samsung TVs, throw it up through the roof and escape into the night, right? That's what those are there for. What they don't protect you from is if I fall into that skylight, what's going to happen? I'm going to get cut. The debris is going to fall down to the people below. And we don't know what that screen is rated for. It actually probably isn't rated for 2 times intended load, which is the OSHA requirement for fall protection, because it's flat. The strength that we get when we build skylight screens is in the dome, typically, because it's bubbled up. That gives us a lot more strength when it's designed that way. So if you're going to have skylights, they've got to be safe. Again, we design skylight screens that are designed to go over the top of the skylight. We use tension to fit basically a channel on either side. The screen sits in that channel and keeps you safe from falling through and into the skylight or breaking the dome. Or we use a non-penetrating guardrail called key dome that we put around the skylight. We use PVC weights to kind of box out that curb so that we can't fall through the skylight. So thinking about your facility, think about the skylights. Are they protected? Do not believe hey guys, we got fall protection on our skylights. Oh, our skylights are fall rated. They probably aren't. If you're really curious, go through and check the manufacturer. But if it's got a bubble on it, chances are it's a plastic PVC or just a plastic polymer dome that's basically being broken down in the sun that needs to be protected. So think about that. I'm trying to think through, my experience with actual accidents in fall protection, and the majority of them have been through skylights. I was fall protection expert witness on a fall case, and it was a roofer through a skylight, cleaning the roof, slipped on the water, fell through a skylight, 30-foot fall. We got a call. This is a crazy side story. We got a call a month and a half ago. There was a school where the students of the school broke onto the roof. Somehow they figured out how to get up onto the roof, and they were using the skylight as a trampoline. They would jump onto the bubble and it would invert, and then it would pop and it would launch them. And they would see how far they could launch. Well, obviously, after 2 or 3 jumps, one of the kids crashed right through the skylight over the gym. It was a 30-foot fall. There was a folding table right below the student. He broke through the table, and that saved his life. He didn't die. But what are the chances of that being there? And they called us like, do you guys do skylight fall protection? We're like, yeah, we'll get there overnight. We'll get you whatever you need. It's so scary to have that situation, but stuff like that happens every day. Oh yeah, let's use a skylight like a trampoline. That's a great idea, right? When you're not educated around the hazards, you make bad decisions. And so that's why we do so many webinars, is to educate around these hazards. Okay, talked enough about skylights. Got 20 minutes left in the hour. Let's start talking about the leading edge. And I always like to remind people, if you have questions, start to add them into the Q&A. We should have about 10 minutes at the end for me to answer questions as they come in. All right, so let's talk about the leading edge. The code that addresses this in OSHA is 1910-28, subpart B13, and we have 3 sections, okay? OSHA has updated this portion of the code in 2016, like I mentioned, has updated this portion of the code. Before, it was super confusing. It just said that any edge 4 feet or more above an adjacent edge must be protected by a full perimeter guardrail, no matter what. It's like, wow, that is a wild requirement. Now, what OSHA is required is what we call a zone defense. So we have different zones, and when work is being done in each zone, there's different fall protection requirements. So we're going to work from the outside, the edge, and work into the middle of the roof, and we're going to talk about each of these zones. Zone number 1 is work that's being done from 0 to 6 feet into the roof edge. So work performed less than 6 feet of the edge. This is what we call the critical zone in fall protection. Think of it this way. When you fall, no one trust falls, right? When you're working, you don't just plant your 2 feet, cross your arms, and just fall straight backwards, right? There's a slip, a trip, then a fall, right? So you slip or trip, you take 2 steps before you lose your balance, and then you lose your balance and fall. So the average worker, let's say, is 6 feet tall. You take 2 steps, you're going to travel 4 to 6 feet and then fall. If that trip or slip is in the direction of the edge, your center of mass is going over the edge in this zone. So if I'm working within 6 feet of a roof edge, an untied shoelace, a stubbed toe, tripping over a tool, any just random accident can be fatal. That's why this is such a critical area. We're less than 1 body length away from the roof edge. So any misstep could prove to be fatal, which is why the requirements in this zone are so high. The code states that when work is performed less than 6 feet from the edge, the employer must ensure each employee is protected from falling by use of, and now we have options. So I need to be protected from falling by use of a guardrail system, makes complete sense, safety net system, so a net literally below you, and you fall, it will catch you, travel restraint system, you guys already know about that, or a personal fall arrest system, you guys already know about that. So we've got 4 options. Personally, I've never seen a net on the side of a building to catch somebody, but that's what you want to do, more power to you. But basically what OSHA is saying is if you're working within 6 feet of the edge, you got to be protected. You got to have guardrail, net, tie off, anchor points, lifelines. You got to have something there to keep you from falling. No exemptions, nothing. You need to have it. And by the way, a safety monitor is not considered safety in general industry. That's only in construction for roofers doing roofing work. And a painted line isn't either, but I'll get to that in a minute. Next, when work is performed from 6 to 15 feet from the edge, so we're now at 1 to 2.5 body lengths away. The employer must ensure that each employee is protected from using guardrail, netting, restraint, arrest. And then it says that the employer may use a designated area when performing work that is infrequent and temporary. So I have 3 new terms. We can use a designated area. What is that? What's a designated area look like? A designated area is a flag system. It is very clear in the code that it is a physical barrier, so it's not a line painted on the roof. It has to be at least 39 inches tall, sag no less than 34 inches, visible from 20 feet. That's the code. So I have to have a flag, a warning line system, and I can only use a warning line if the work being done in that area is temporary and infrequent. Temporary means that it takes less than 2 hours to complete in a single trip, and infrequent is less than once a month, according to federal OSHA, less than once per quarter, according to Cal OSHA. So pretty simple, understandable stuff. Then zone 3, any work that's 15 feet or more from the edge. So now we're almost 3+ body lengths away, right? So if I do a slip, trip, and fall, my body is not going to be anywhere near the edge. I'm feeling pretty confident at this distance from the edge. It states that each employee needs to be protected from falling by guardrail, netting, arrest, restraint, designated area. And then it goes on to say that the employer is not required to provide any fall protection, provided that the work is infrequent and temporary, and we implement and enforce a work rule prohibiting employees from going within 15 foot of the roof edge. So OSHA's saying you don't have to do any fall protection if the work's greater than 15 feet away, as long as you do it less than once a month, as long as it takes less than 2 hours to complete in a single trip, and as long as you have work rule and training, telling people and informing them what type of protection is required if you don't meet those requirements. And you can enforce it, which means that the equipment is in place, and you can use it, right? So what does that look like in the real world? A lot of places, any units within 15 foot of the roof edge will protect with a guardrail corral. Any units outside of 15 feet, you're allowed to work on. And we have temporary anchor points that we can move around the center of the roof, that if the project's going to take longer than what we think, we can use the anchor point. Or we corral in at 15 feet. We connect the corrals with warning line full perimeter. We have one temporary anchor point that we can move if for whatever reason we need to work beyond where that warning line is. You tie off, you go underneath, you do your work, and you come back, right? So those are some of the ways that we integrate or implement this plan. This is that same code, but as a graphic. So showing the closer that we get to the roof edge, the higher our risk rating is. And these are the allowable solutions. Take this same concept, apply it to our risk assessment matrix earlier, and it follows right along. Meaning the closer to the edge my work is, the higher the likelihood of a fall. So the more critical it is that I protect that area. So that's why when we look at your roof, we look at the access points, we look at any openings, and then we look at work on the edge, outside in. And that's how we prioritize protecting your roof and the roof areas, to take a very complicated, daunting subject and break it down and make it very easy. Frequently asked questions. Number 1, how does OSHA define temporary and infrequent? I already talked about that. Number 2, can I use a painted line as a designated area? No, you can't. OSHA in the Federal Register, I mentioned it earlier, states that it has to be a physical barrier. It has to have height to it. 39 inches with sag no less than 34 inches. It has to be set at least 6 feet away from the roof edge. The main reason, I'm from Buffalo. We get snow in Buffalo. I know that's a big secret. Nobody knows that. But the minute snow is on the roof, you don't see that line, right? So how do I go up on the roof in the winter and service it safely if I can't see the fall protection that's up there, right? Same idea as what I was talking about with skylights. And OSHA in the Federal Register clearly states that lines are not, right? What if somebody puts plywood over the line? What if it gets painted? What if dust gets on top of it? a painted line is not considered fall protection. Another side story, because we see crazy stuff. We had a client, they had a ballasted roof, which means they had rocks on it, and they used a painted line as their demarcation, but the rocks kept shifting, so the line kept moving. So they had to repaint the line every day, every year, and it took more than 2 hours to do. So their fall protection required them to work within 6 feet of the edge, not protected. Every time they repainted it every year. So it was just like, we're doing this wrong, guys. Let's go into the code. The code's there for a reason. It needs to make sense. What we're doing needs to make sense. As far as rooftop guardrail, we do non-penetrating rooftop guardrail designed to exceed all OSHA performance requirements without poking holes in your roof, without voiding roof warranties, with a 30-year life expectancy, because everything that we do is galvanized inside and out. Our demarcation or warning line designated area is a non-penetrating warning line as well. Integrates a 100% recycled PVC weight with high-vis flags visible from 20 feet. And then finally, last concept that I want to kind of leave everybody with is talking about the hierarchy of fall protection. So what this means is that I know I need to protect the roof. I know I have areas that need to be protected, but what's the best solution, right? I can do anchor points. I can do lifelines. I can do safety nets, warning line, guardrail, skylight screens. What's the best solution? The higher on the hierarchy, the better the solution. This is an adapted version of the hierarchy of controls that we've applied to fall protection. Number one, the best solution is to eliminate the hazard completely, right? Here's our rooftop example on this side. So if I'm talking about skylight fall protection, roof over the skylight. You can't fall through a skylight that's not there. Genius, right? Who knew? That's the best solution. It might not be the most practical solution, right? We might get lead points. We may need to get natural lighting into the building. It's better. So it might not be an option, but it is the best solution. If that's not an option, we go into what's called collective fall protection, which is a barrier. Cover the skylight, put a guardrail around it, protect the edge. It's called collective fall protection because it doesn't matter if I have one person or 100 people on the roof, they're all being protected. I'm protecting the collective group, right? So we can set up that fall protection and I could protect everybody. Next, we go into work restraint and fall arrest, which we've already defined. But this category, these two together, are what we call active fall protection or personal fall protection, because I have to actively engage. I have to tie off. I have to put on a harness. I have to inspect the harness. I have to engage with the equipment, and it doesn't protect me unless I'm using it properly, right? So I can have two people on the roof, one safe, one not, because one's tied off and one isn't. Versus collective, everybody's safe. The minute we jump from a collective to a restraint system, the amount of risk that we accept as the owner jumps a standard deviation higher because people need to use the equipment properly. And statistically speaking, when you're left to pick between doing what's safe and what's convenient, chances are you pick what's convenient first. Then when we jump from work restraint into fall arrest, we go another standard deviation of risk higher because a fall is actually going to occur. And when a fall occurs, I need to, one, have enough fall distance for that to safely happen. Two, I need to have a rescue plan in place to get that person down in less than 15 minutes so they don't have suspension trauma set in from hanging on the side of the building. And three, I need to know that they fell, right? I need a warning system, a buddy system. I need a robust monitoring system to make sure that I know when somebody fell off of my building who's probably unconscious because they probably slammed into the side of the building. So the question becomes, what is the best solution? We want to eliminate hazards. If we can't eliminate, we want to integrate barriers. If we can't integrate barriers, we want restraint. And if last resort, we want to do fall arrest. So with that, in closing, for our architect and engineer friends, check us out on MasterSpec and RCAT to specify our products. If you have a roof, we offer complimentary rooftop site assessments. So we have 25 experts. They're all fully trained on OSHA and how to integrate and make your roof safer. So if you would like a complimentary rooftop safety audit to take a look at your roof, understand traffic patterns, frequency of exposure, and how to solve it, the first step is to have us come out and do a complimentary walk with you and understand that. With that, I'll pass it over. We have 5 minutes left for questions. I'll give it back to Kevin to see what questions I can answer.
Excellent. Great job, Dan. Thanks for sharing your insights and expertise. Before we do start the Q&A, I just want to let everyone know about the evaluation survey that we're asking you to complete. The survey will open in a different screen after this webinar. As always, we appreciate your input as it's very important and helps us improve our future webcasts. With that, we will get to some questions. First one asks, can you mention and go a little bit more into the requirement for inspections of your fall protection, saying they're struggling with finding vendors to inspect the different fall protection systems on the roofs each year?
Good. That's a very good question. So it depends on the system that you integrate, right? If you have an active system, meaning it's a anchor point or a lifeline, that needs to be inspected every single year by by the person who installed it, ideally, or a competent person who has been trained by the manufacturer of that system to inspect it. Though that is like every industry in the US, there's less and less and less experts available. The best solution is to integrate collective fall protection. Collective fall protection just requires an annual visual inspection by any worker, because all you're looking for is that it's still fit for use, that it hasn't been messed with, moved around, and that there's no work being done outside of that. There's no engineering involved that you need to test connections. We're not checking tension. We're just looking for basically that it's still fit for use and that it hasn't been vandalized. And it's a simple checklist that comes in our O&M manual. You look at the system, you look at these 7 things, you check it off, and your own employees are able to do that versus having a vendor have to come in and do a formal inspection evaluation of your anchor points or lifelines. So the system makes a difference. If you haven't invested yet in fall protection, what we want to do is think about those costs later down the line that you have to deal with.
Thank you. All right. Next question asks, does a parapet wall serve as fall protection? And if so, what is the required height?
These are good questions. We got a smart audience. So yes, a parapet does meet the fall protection requirements for a barrier along the leading edge if it's 42 inches plus or minus 3 inches. So the lowest your parapet can be is 39 inches to be in compliance. A lot of clients that I have, they'll have like a 30-inch parapet, and they'll be like, well, I'm close enough. It's fine. Don't worry about it. It's pretty tall. That's not a good answer, and it's all about physics, right? 39 inches is above the center of mass of the majority of the population. So if I bump into something 39 inches tall, it's going to be above my waist, so I can't topple over it. If I bump into something that's 30 inches tall, it's below my waist, my center of mass can go over it. I'll topple. So that's why that minimum height is at 39 inches, because I think it's less than 5% of the population is tall enough that it would be below their center of mass. So that's the reason for the height requirement of 39 inches minimum.
All right. Looks like we've got time for one more question. And this one asks, can roof tiebacks be used for fall protection? And do we need to be current on the SID inspection to use them, or can a competent person do a visual?
Yes, tiebacks can be used as fall protection, but fall protection anchors can't necessarily be used as tiebacks. So yes, you can use them. No, you can't just do a visual. It has to be inspected by a competent person. I'll give you an example, because we have partners, that we work with every day that go out and inspect these and you have to pull test them. Looked at the anchor, it's flashed into the roofing, right? You have a flat roof, it's flashed. Everything looks good. You do it one of these, it feels pretty sturdy. Okay, cool. They test it anchor to anchor. They put the chain on it. They start to pull in. It folds right over. And they're like, what's going on? Well, what happened is that an electrical contractor came in. He had to hang conduit in the ceiling below, and there was this big plate in the way. So they just cut it off. Well, it was the bottom plate that was holding the anchor on the top of the roof. They just cut it off so that they could mount their conduit underneath it. A visual inspection wouldn't catch that, right? That's why you need to have an expert who knows how to test them come out and do that, because there are crazy stories that we see. Sometimes, yeah, the roofer installed them, they're fine, right? You test them, and they never tighten the bolts. They just drop the bolts and they never put the nuts on the bottom. Just crazy stuff happens. So if I'm going to be tied up to something that I could fall on, I want to know that it's been inspected by a competent person, that it's safe.
All right. Well, thank you, Dan. Unfortunately, we have run out of time today. We're sorry we didn't get to everyone's questions, but all of any unanswered questions will be forwarded along to Dan. Once again, we hope that you take the time and fill out the forthcoming evaluation survey and give us your feedback. With that, we end today's Safety and Health Magazine webcast. We'd like to thank Dan Huntington, everyone at Key Safety, and all of you who listened in. Thanks and have a great day.